Okay, Algebra kids, it's me. Yay. Day one. First thing we're going to be doing today is, and I'm going to try to do this as quickly as possible because this is taking me way too long. I keep going back and changing stuff and going crazy. All right, COVID day one. We are going to be doing the beginning of the review for the polynomials test. You received the copy of the polynomials test in your Google Classrooms. Now, Logan brought up a really good comment. Why don't we do Zoom? Okay, get the district to do Zoom. Zoom is a great project. We do have Google Hangouts and Google Meet that we can create. The only problem is everybody's got to be on the same page at the same time and the same ability to get to the Zoom regardless. We can maybe do that as time to come. We've got a lot of time to figure this out. So that's a great idea from Logan. Maybe we'll try a Google Hangout for some people when we get some times. I am here. I'm available 8 to 3. I'll have my video for you there. You can send some emails and I'll respond to you before 3 o'clock tomorrow. Now, if you send me an email at 3 o'clock, you probably won't get a response from me, maybe till the next day, maybe that evening. I don't know. But I'll try to be accessible as much as I can within here and as much as possible for you. This is weird, people. This is a really weird time. And now we're out till the 30th. This is going to be the worst video that I make by far. Okay? It will get better because it can only get better. I'll get better with these, make better videos, make them more concise, quit talking as much, and get as much help to you. Now, in these videos, like I said before, what I'm going to be doing is I'll answer questions that you've got. I'll work through some problems, give you some examples. This first 3 days is going to be just reviewing the polynomials work. Now, you can look through the test. There's no rules that say you can't look through the whole test. You can work out the whole test. That's great. Nothing's going to be assigned or nothing's going to be collected until Friday this week of that test, okay? It's your study guide. How do you collect it? Take a picture of it. Send it to me in an email. Work out the problems on a piece of paper. Do that. Print it out. Work it out your way. Now, if you don't have a printer, you can always just call the middle school and say, hey, I need this printed out. Could you have this printed out for me? And they will have it waiting for you to be able to use there. Now, let's say you work it out on a Google Doc or a Google Sheet. Send it to me. That's no problem. Any way that you can get it to me is good. Just get it to me. Get me some work so I can help you out. Ask me questions. You guys have had some great comments. I'm not that bad looking. That's a lie. Okay, sort of scary looking. I'll try to get a better angle for this so I don't look like I'm a giant coming down onto the camera. I'm wearing a dress shirt, but I'm also wearing jeans and my slippers, so it's Kovoid. Now, what we're going to do today, we're going to do 3 different little parts, okay? A, number 1, adding and subtracting polynomials. Very general. Adding and subtracting polynomials is really pretty easy. After we get done with adding and subtracting polynomials, then it's just going to be multiplying polynomials. That's the FOIL method, that's the lattice method, that's the distributive method. I don't care which method you use, any one of them. That's all we're doing today. It's going to be fast, it's going to be quick, it's going to be easy review. First problem, let's see if you can write it out as I say it. It says, the quantity of 8x to the third power plus 11x, the quantity of 8x to the third plus 11x, plus the quantity of 5x to the third power minus 2x to the second power plus 7x plus 9. Okay, see if you wrote it out correctly. Okay, here's my smartboard. Smartboard. All this, let me back up so you can see it. 8x to the third power plus 11x, the quantity of, plus the quantity of 5x to the third power minus 2x to the second plus 7x plus 9. Now, how do we solve this, simplify this expression? Simple. Combine like terms. X to the thirds with x to the thirds. X to the seconds, there's only one. X's, combine the x's. Constants, bring it down. Some of you may like just lining it all up. X to the thirds over x to the thirds and so on. Put the longer problem on the top. 5x to the third on the top. Put the 8x below it. 8x to the third and put the positive 11x below that. Okay, I've condensed the problem instead of being this big long mess, now it's just like terms over like terms, and I can just go straight down. Since it's addition, you just add them. Add the like terms. 8x to the third and 5x to the third makes 13x to the third. 13x to the third power. There is no other 2x squared, so just bring it down. It's a negative 2x to the second. 7x and 11x, they're both positive, so it makes 18x. And there's no other 9, so just bring down the 9. We're done. Here's your answer. 13x to the third minus 2x, backwards and upside down for me, 2x to the second, plus 18x plus 9. In that order, descending variable order. If there's multiple variables, you have to combine the like terms with the like terms. That's as easy as that. Now, how do I make this problem a little more difficult? Change the addition sign into a subtraction sign. Okay? Do this problem on your own. It's a subtraction problem. Try it. Pause the video and work on it. Okay? Now you've brought it back. This is what we're looking at. That negative sign changes everything in that hideous long parenthesis to its opposite. Okay, I'm just erasing the work from the last problem. That negative sign changes everything in here to its opposite. This is no longer a 5x to the third, it's a negative 5x to the third. Not a minus 2x, it's a plus 2x to the second. Let me write it out, just so you can see it. The negative sign changes everything. This becomes negative 5x to the third. This becomes a positive 2x squared. That becomes a negative 7x, and that becomes minus 9. So that whole second part of the equation changes to its opposite value because of the negative sign. Simple enough. Everything changes to its opposite. Now we bring the 8x to the third and the plus 11x to combine with its like terms over here. And let's just do it the same way we did it before. Line up the variables. You've got a positive 8x to the third and a positive 11x. I line them up with their counterparts in the problem. A negative 5x to the third, positive 8x to the third should make a positive 3x to the third. Simple enough. A positive 3x to the third. There is no other x squared, so it's a positive 2x squared. Positive 11x, negative 7x should make a positive 4x and bring down the negative 9. So, adding and subtracting, done. Combine the like terms, done. Alrighty, should be 3x to the third. 3x to the third plus 2x squared plus 4x minus 9. Simple enough? Alrighty. Now, if you had a problem with that, I know I zipped through it, but you've got some problems to practice on that study guide, the test for the polynomials, okay? You've got some problems that you can practice with. Now, last but not least, FOIL method. Multiplying two binomials or multiplying trinomials. Let's start with simple binomial. The quantity of x plus 7 times the quantity of x minus 9. I'm going to zip through a handful of ways that we can do this. FOIL, first, outside, inside, last. FOIL, first, outside, inside, last. First, x times x is x squared. Outside, x times negative 9. That's a negative 9x. Inside, 7 times x is a positive 7x. Last, 7 times negative 9 is negative 63. Using the FOIL method, it lines it up nice and neat. You've got your OI, outside, inside, right in the middle here, combining together. Okay? A negative 9x and a positive 7x make negative 2x. Bring down the x squared, bring down the negative 63. Simple dimple. Okay? X squared minus 2x minus 63 is what this turns into. Okay? How would you do this same problem using the lattice method? I'm going to fly through this. The distributive property basically is exactly the same as the FOIL method. It's just called distributing the x through it, distributing the 7 through it. I'll show it to you afterwards, but let's just do the lattice method right now. Okay, you've got the x and the -9, you've got the x and the 7. Wow, that was cool. Okay. X times x, x squared. X times -9 is -9x. 7 times x is 7x. 7 times -9 is a -63. Tough to write upside down. Okay? Diagonals. You go diagonals in this. Okay? That's an x to the second power. Right there. Diagonal. A -9x and a +7x. Make a -2x minus 63. Okay? That's the lattice method. If you prefer the lattice method, I don't care. Use the lattice method. Honestly, the lattice method works better when it's a binomial times a trinomial. Okay, now like I said, I'm just going to fly through the distributive property for FOIL or for multiplying binomials because it's the same as FOIL. You're distributing the x through this. X times x, x squared. X times -9, -9x. Now you're distributing the 7 through this binomial. 7 times x is 7x. 7 times -9 is -63. It's the same thing that I just explained. First, outside, inside, last. Same monster, same way of doing it as the FOIL method. It's just called the distributive property or the distributive method. Yay. Okay, old t-shirts come in handy. All right, now, what if you've got a binomial times a trinomial? Let's say we've got the quantity of x plus 11 times the quantity of 2x squared minus 3x plus 2. All righty. We've got these two expressions, and we're multiplying these two a binomial times a trinomial, these two polynomials, and we have to multiply them. FOIL's not going to be that great. The distributive property works nice. I have to distribute x throughout everything over there. Everything gets multiplied by the x. X times 2x squared, 2x to the third. X times 3x is 3x squared. X times 2, 2x. Then I have to distribute the 11 through everything over there. 11 times 2x is 22x squared. 11 times 3x is a -33x. And 11 times 2 is 22. Line up the problems. Let's see what I just explained. Distributing the x throughout. X times 2x squared is 2x to the third. X times 3x is a -3x squared. X times 2 is a +2x. See, distributed the x throughout the first set, or throughout the second set of parentheses. Now you're going to distribute the second part of it, the 11. 11 times 2x squared is a +33x squared. Oh, sorry, a +22. A +22x squared. 11 times -3x is -33x. And 11 times 2 is a +22. Now, if you look at how I wrote this, it's lined up. X cubes over nothing. X squareds over x squareds. X's over x's. Constants over nothing. Okay? So you just add and subtract straight down. Bring down 2x to the third. The +22 and the -3 makes a +19x squared. The -33 and the 2 make a -31x, and bring down the 22, and it's positive. That is the distributive method for a binomial times a trinomial. You can use the lattice method for this. Let me erase this work here. Let me get it close so you can see it. It's better this way. Looks a lot better that way, covering my face. All right? Now, really quickly, same exact problem, only now we're going to use the lattice method. It's a 2x3, so basically it's a rectangle. And you've got your 2x squared there, your -3x, and your 2 there. You've got your x there and your 11 there. You can set it up either way. You can go 3 this way and 2 that way. Doesn't matter. Same monster, same thing. Okay? X times 2x squared is 2x to the third power. X times negative 3x, negative 3x squared. X times 2 is 2x. See, all I did was take my x here and multiply it by each part up there. Fill it in. Next one, 11 times 2x is 22x squared. 11 times negative 3, negative 33x. 11 times 2 is 22. Okay? 22x squared, negative 33x, 22. Diagonal adding or subtracting. There's nothing for the 2x to the third. 2x to the third. Negative 3x squared and 22x squared still makes a positive 19x squared. Negative 33 and 2 makes a negative 31x and a positive 22. Should be the same answer that I just got on the last one. I don't know if I made a mistake with my adding. Hopefully I didn't. You guys caught it, and you can send me the email and go, Mr. O, you made a mistake. But on this one, I don't think I did. So that's what you're doing for tonight. This is a 16-minute instructional video. You're supposed to be doing 30 minutes of math every day. So by the time I get done blah, 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 you're going to have about 13 minutes of work to do. All you're supposed to do for your homework for tonight are that first page, basically, of multiplying and adding binomials. I think it goes to number 5 on the next page. Okay, 5 or 6 on the next page. The first few should be very, very easy. I hope everybody's doing well. If you have any questions, email me. Bring your problems in. We'll work on them. See you tomorrow.